my dear students, class 10. We have taken a topic for you that is coordinate geometry, derivation of distance formula. So let's start. How to derive the formula that is distance formula on a Cartesian plane. Okay, now you look at a Cartesian plane and this is x-axis and this is y-axis and you see 2 points A and B. So 2 points on the line segment AB are drawn obliquely or tangentially. So we have to find out the distance between A and B. What's the formula? How to derive it? But here is a question, why not AC? Why not BC? But AC is parallel to x-axis and BC is parallel to y-axis. But we can easily find out their distance using with the help of the coordinates. You know, a point on a plane can be described by two coordinates, x coordinate that is called abscissa and y coordinate that is called coordinate. Now you see, so A is a point, here it has two coordinates, let x1 and y1. And at point C, x2, y1. Why y1? Because the perpendicular distance from x-axis to A is equal to the perpendicular distance from x-axis to C are equal. So this is y1 and y1. And simply subtracting x1 from x2, x2 minus x1, that is the distance of AC that we have explained here. AC distance is x2 minus x1. We have reflected here. Similarly, we can find out applying this principle. So let us find out the coordinate of the point B. Here B, x2, y2. Because here x2, y1, but here x2, y2. Now you see x2, the x coordinates are equal here. Why? Because you see the perpendicular distance from this point to this point, from this point to this point, from this point to C is equal to from this point to this point. So that is the abscissa are equal or same at 2 points, that is C and B. Means the perpendicular distance from the y-axis to the point B is equal to the perpendicular distance from y-axis to the point C. So x2 and y2. Sorry, x2 and y2 and y1. And now subtracting y1 from y2. So y2 minus y1 is the distance between BC. So it is very simple calculation we have mentioned here. Y2 minus y1. So this we have already mentioned. Okay. So easily we can calculate only by with the help of the coordinates. But how can we find out the distance of AB? So AB line segment. Okay. So let's find out. So at point A, coordinates are x1, y1. Okay. Now point B, x2, y2. Okay. At point C, x2, y1. So these are the coordinates we have already mentioned. So let's find out the distance. Now you look at ACB is a right angle triangle at C. Means the right angle at C. The measure of the angle at C is 90 degrees. So AC is the base of the triangle and BC is the height, that is perpendicular, and AB is the hypotenuse. Okay. Now AC distance we have already discussed, that is x2 minus x1, and BC height. So that is actually base P. So BC is equal to P, perpendicular. So that is y1, y2 minus y1. So let's apply the Pythagoras theorem. So AB, this is hypotenuse. A, that is hypotenuse, is equal to P square plus B square root over. So root over of P square plus B square. So we have mentioned here. So hypotenuse. This hypotenuse means AB is equal to P square plus B square root over. So let's put the distance value of P and B that we have derived. So here AC is B. So P square minus B square. In any way, P square plus B square. What is P square? That is Y2, that is B square. Y2 minus Y1 whole square, that is P square, BC square. And AC square, the same. You can write B square plus B square or B square plus P square. Okay. So that is AC. AC x2 minus x1 whole square. That is, this is B square, this is P square. Okay. So B square plus P square root over. That is the distance formula of AB. So putting the value of P square and B square and means finding out the root of their sum, we can find out the AB distance. So distance formula is clearly x2 minus x1 whole square plus y2 minus y1 whole square, because we have taken first x coordinate, then the y coordinate. Okay. So we can find out from this, we can find out the x coordinate and the y coordinate. Now AB distance we can find out this using this formula. So it is very easy to calculate the AB distance. Okay. Now let's discuss some important concepts which are associated or connected with this Cartesian plane and the x-axis and y-axis. So you see a point on x-axis. Here is a point. Let's take an example. Here is a point on x-axis. So this is the abscissa. So abscissa, it may be any unit. So we can write x, 0. So means the x coordinate has some units. So x, but y 0. So all points that lie on x-axis, the y coordinate is always 0. So this is important. This is over. And a point on y-axis, you see here is a point on y-axis. Now you see this distance is your y-coordinate from origin to this. So it can be expressed in terms of units. But what is the unit of x or abscissa? Abscissa is 0. So now x coordinate is 0 and y. It can be written as 0, y. So you see a point on x-axis, two coordinates are x, 0, and a point on y-axis, two coordinates are 0, y. It's very important. Please remember. Then, if x is 0, where x is 0? You see, look at here. X is 0. When x is 0, that implies equation of this y-axis. Okay. So all points that lie on y-axis, the coordinate of x is always 0. Coordinates of x are 0. So it can be expressed in form of a linear equation in two variables, that the standard form ax plus by plus c equal to 0 we can express. So here you see x is 0, 0x and 1y, because coefficient we have taken 1, it may be some units. So 1y and 0 c equal 0, that is the form we can express. And if y is 0, so look at why, if y is 0, we see here. If the x coordinate and y coordinate is 0, that is the equation of, when y is 0, the equation of x axis. Okay. So on x axis of each and every point, for each and every point, y coordinate is 0. Okay. So this is the equation of x axis. Now it can be expressed in form of a linear equation in two variables, that is 1x 0y, because y is 0, y 0 and 0 0. Okay. So it has been taught in class 9. And another concept you please remember, if x is a unit, if x is a unit, you see, suppose this is a point, so a unit, I mentioned this distance. And if x is a unit, then that will be a straight line parallel to the y-axis. A straight line parallel to y-axis. You see, that is extended. Okay. And if y is a, and you see y distance, you see from this point to this point, that is a unit. A unit. If we take a unit, here we have mentioned a unit. Now, this perpendicular distance from origin to that point and from x-axis to that point are equal. That is a unit. So this line will be parallel to the x-axis. So this is important. When x is a unit, a straight line that is parallel to y-axis, and if y is a unit, and that is the straight line is parallel to x-axis, and here the line is parallel to y-axis and this line is parallel to this axis. So these are the major concepts you have to remember and apply in working out and finding out solution to the problems on distance formula, applying the distance formula. Please stay tuned. Hope you have understood the basic concept. Stay tuned to watch our next video. In next video, we shall solve some problems that were set in previous examination based on the principle of distance formula and the points that lie on the x-axis or y-axis. Thank you all for watching. If you like, you may subscribe and share to watch our series of videos. Thank you all for watching.